Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Dundigal, Hyderabad. In this session, we are going to study the definition and terminologies of introduction of kinematics of machines. This is the subject related to 4th semester mechanical engineering, and here first module 1 is related to introduction to kinematics of machines. In that, the subtopics are: what is the classification of kinematic pairs, what is the inversions, and what is the degree of freedom. Now here, let us begin with the definition 1. What is mechanics? Because kinematics of machines, the prerequisites for understanding the kinematics of machines is engineering mechanics. First, what is mechanics? Mechanics is the branch of scientific analysis which deals with the motion, and motion, time and force is known as mechanics. In mechanics is divided into two parts. One is statics, another one is dynamics. Statics and dynamics. Statics and dynamics. What is statics? Statics means the study of the forces and its reactions when the body is at rest. What is dynamics? When the body is at motion. Again, dynamics is divided into kinematics and kinetics. In kinematics, coming to the what is kinematics? Kinematics is the study of motion without considering the force causing the motion, which produce that motion. Without considering the forces which produce that motion is kinematics. Okay? And this kinematics deals with kinematics of machines. Now coming to our subject, that is kinematics of machines. This kinematics of machines deals with the study of relative motion of parts, machine parts. Relative motion means it involves the study of position, displacement, velocity and acceleration of various components of machine. That is kinematics of machines. That's why the syllabus included in kinematics of machine is: the first module is introduction to kinematics of machines. Second module related to the velocity and acceleration diagrams of various machine components or various mechanisms. Again, velocity methods. Again, velocity analysis includes, there are two types of methods. Number one, relative velocity method, and second method is instantaneous center method, I center method. The third one is called acceleration diagram. This acceleration diagram, so we'll draw acceleration analysis we'll do by using acceleration diagrams. That is also by using relative method of graphical methods. Graphical method will apply here. That is what kinematics, what is kinematics and what is kinematics of machines. Next, coming to dynamics, it involves the study of forces acting on the machine parts and the motions resulting from these forces. That is dynamics. Okay, again, as I explained here, dynamics part is kinematics and kinetics. Next, important definition to understand for kinematics of machines is that what is a plane motion. Here we consider plane mechanisms. Planes means two-dimensional. Here we study only two-dimensional analysis. We don't go for three-dimensional. So the plane motion means, suppose if your body is having plane motions, that body consists of whatever points, whatever link, that all having same planes, in planes which are parallel to some reference plane. So all moves in a plane motions. Next, in coming to the various motions, rotary motion, translatory motion. Okay, what is that rotary? What is the translation? So it is a body has a translation if it moves so that all straight lines in the body move to parallel positions. So there is rectilinear translation. This rectilinear translation is a motion wherein all points of the body move in straight line paths. That is a translation. And rotary means angular motion is called rotary motion. Now translation motion related to that, in the case of kinematics of machines, this slider crank mechanism. In slider crank mechanism, it is a crank. This is the link 1 and it is link 2, link 3 and link 4. Link 1 is a fixed link, whereas link 2 is having complete revolution, complete rotation. That's why it is known as a crank. And link 4 is having translatory motion. It moves, sliding. When link 2 is having the rotary motion, then link 4 moves. Then what is the motion of link 3? This link 3 is known as coupler rod. This coupler rod is having combined rotary and translatory motion. Why? Because it is having 2 joints. Here, 2 nodes. Here, one joint is connected to link 2. That is in pure rolling action, rotary motion. And another joint is connected to link 4. It is in translatory motion. That's why link 3, the motion of the link 3 is the combined rotary and translatory motion. So it is a coupler rod. The motion of a coupler rod is combined rotary and translatory motions. Next, coming to the types of links. What is a binary link, ternary link and quaternary link? If the link which is connected to other links at 2 points, that is known as binary link. It is a single link but having opportunity to connect two other links, other two at 2 points. This is a binary link. Whatever shape may be, but it is having only 2. It may be like that. It is having only 2 nodes, opportunity to joins. It may be in this direction. It is having only 2 joints so that you can connect another link. This link is known as binary link. Okay. What is a ternary link? Ternary link means, now coming to binary link application. This link 2 having 2 joints here. At one joint is connected to link 1, at another joint it is connected to link 3. So this link 2 is a binary joint. Link 3 having is also binary joint. And link 4, if you consider the slider, it is with respect to link 1 and also link 3. This is also binary. And wherever was link 1, it is having only one joint connection. It is a single joint, fixed link here. Now the links 2, 3 and 4 are binary joint because one joint is here link 4 and it is connected to link 1 also. It is sliding, no? Okay. So that's why it is the link 4 is having. So link 2, 3, 4 are binary joints. Coming to ternary link. What is the meaning of ternary link? The ternary link means if a single link having an opportunity to connect 3 other links, 3 links having facility, that is called ternary link. Whatever shape may be, it is 3 joints connection. It is ternary link. Okay. It is also ternary link. So these are all ternary links. And quaternary link means, quaternary link, if you consider the link having 4 joints to connect 4 other links, it is the quaternary link. It is quaternary link. So generally this type of links are used in the case of, suppose 4-bar mechanism is there. In the 4-bar mechanism, all links are binary links. 4-bar mechanism, it is a binary link. Link 1, 2, 3, 4, or 1, 2, 3, 4, or 4 are binary links. Okay, 1, 2, 3, 4 binary links. Now quaternary means, how to represent quaternary link? The quaternary link is shown like that hatching line, but with 4 joints facility. That is quaternary link. So that is the concept of types of links. Okay, what is binary link, what is ternary link, and what is quaternary link. Now, next definition, that what is the term we are calling as a link? What is the term link or element? Okay, a link is a rigid body, that is rigid link, whose deformations are so small that they can be neglected in determining the motion parameters of the link. So here the definition is elaborately explained. So it is, the link is the body, any body which has motion relative to other body. Then that component is known as, or that body is known as link. This link or element is the terminology related to kinematics of machines. Machines terminology, link, element, joints. Now, very important definition in order to find out, in order to do analysis, kinematic analysis of various mechanisms, the important term is the degree of freedom. It is in short form DOF. What is the degree of freedom? The number of independent coordinates required to specify the complete configuration of a body in space. Then it is known as a degree of freedom. In vibrations, the definition of the degree of freedom is that the number of independent coordinates required to specify the complete configuration of a system is known as a degree of freedom. Now here we can explain more elaborately in detail the degree of freedom, how to quantify it. We can quantify by visual inspection for some of the mechanisms, and there is mathematical formula that is called Grubler's criterion, that is degree of freedom of plane mechanisms that equal to n equal to 3 times L minus 1 minus 2j minus h, where L is number of links, J is the joints, H is the higher pair. This J is the lower pair also we can consider, H is the higher pair. Suppose 4-bar mechanism is there. This is a 4-bar mechanism. Link 1, 2, 3, 4. What the degree of freedom for 4-bar mechanism is? The number of links are L equal to 4, 4 minus 1. Number of joints 1, 2, 3, 4. 4 joints. Higher pairs is 0. That means it is 1. Degree of freedom equal to 1. What is lower pair again? What is lower pair and what is higher pair? When there is a relative motion between two links, the contact between those two links is either surface contact or area contact. Then that pair is known as, those two links is called as a lower pair. What is a higher pair? If the motion between the two elements and if the contact is either point contact or line contact, then that pair is known as a higher pair. That is the definition of lower pairs and higher pairs. Now, what is the higher pair here in the case of 4-bar mechanism? Why it is 0? Because there is no point contact or line contact. The joints lower pairs means the joint is complete. It is a surface contact. Okay, that's why it is number of joints are 4. Similarly, we can solve the degrees of freedom for 3-bar mechanism. Okay, the mechanism link 1, 2, 3. How can we know it? What is the degree of freedom? L equal to 3, J equal to 3, H equal to 0. substitute in the formula of the Grubler's criterion, that is 3 times L minus 1 minus 2J minus H. 3 times L, 3 minus 1, 2 times J, 2 times 3 minus 0. 3 2s, 6, 2 3 6 minus 0. It is 0. The degree of freedom equal is 0 for this. When degree of freedom equal is 0, then that type of mechanism is known as a structure. There is no transmission of motion between the links. If degree of freedom n equal to 1, okay, it is mechanism. If degree of freedom is negative, minus 1, then it is known as a superstructure. If it is negative, superstructure. Suppose if your body is in space, what is the degree of freedom of that body in that space? The degree of freedom for that body is equal to 6. How? In the space, x, y, z coordinates. When the body is in space, so this in space body, it is having along x-axis and also rotation, and also it can move about y direction and also rotation along z direction and also rotation about z axis. Now how many translatory motions are there? There are 3 translatory and 3 rotary motions are there. So that's why the degree of freedom for a body in space is having 6 degree of freedom, 6. That is the concept of degree of freedom. Now if you want to do analysis of anything, then we have to convert that physical diagram into the kinematic diagram. Then only we have to do it analysis in terms of line diagram, that is called kinematic diagram. Now coming to lower pair, I have already explained what is lower pair. The examples of lower pairs is that pin joints and shaft rotating in bush, sliding in slider in slider crank mechanism. What is the slider in slider crank mechanism? The slider having contact, there is surface contact on the fixed link. Then that pair is known as this link 1. Suppose link, fixed link, all fixed links are considered as link 1, 2, 3, 4. This link 4 is having contact with link 1 is surface contact. That is lower pair. Suppose if you are touching, 2 hands are clapping, no, like that. Then what type of pair it is? The pair, it is motion is there, rubbing like that. It is lower pair. Suppose if there is a point contact, there is a motion between, motion should be there. Then it is what type of contact? Again, if we consider point, okay, then the point contact between the surface and this point, that contact is known as higher pair. And higher pair example, I am writing with this pen on here on the slate. Then what is the contact between this point to the slate? That is a point contact. Similarly, when you are writing with the ballpoint pen on a paper, then the contact between the ball point to the paper is point contact. Then that pair is known as higher pair. When you are sitting on a bench, the contact between your body and the chair and the bench is the surface contact. Then it comes under lower pair. So this lower pairs we can observe in the case of internal combustion engine, where the piston cylinder, the piston surface is in contact with the cylinder inner body. That contact is the surface, circular contact, the complete surface. Then it is lower pair. Now the contact between cam and follower, the follower and cam is the point contact. All followers and with respect to the cams, certain cams, those contacts, suppose knife edge follower having contact with anything, there is a point contact. And roller follower contact with cam, that is higher pair. And it is a point contact, higher pair. And flat faced follower, when it is in contact with any circular body, then it is also comes under higher pairs. That is the meaning of higher pair. So the examples here, it is mentioned the contact between the 2 gears. So there are teeth are there here, two teeth. It is the point contact. Two circular surfaces are in each other. It is a point contact. Then it transfers. That's why this pair is known as higher pair. Next, what is the sliding pair? When two elements are connected, that one is constrained to have a sliding motion related to other. It is a sliding pair. The link 4 is the slider with respect to fixed link. It is also sliding pair. And link 2 and 3 turning each other. It is a turning pair. Link 1 and 2, it is a turning pair. Yeah, next definition is a turning pair. So the degree of freedom of a sliding pair is 1. The degree of freedom of a turning pair is also equal to 1. So the degree of freedom between sliding pair, it is a sliding, only one directional, okay, translatory motion. Whereas the turning pair, it is only pure rotary motion. There is no sliding in the turning pair. There is no turning in the sliding pair. Next, what is it defined? What is the spherical pair? Definition. Pair means two elements are in contact or having a relative motion between them. Then it is known as a pair. So the spherical pair means a side mirror of your vehicle, the two-wheelers, you can see the mirror can rotate in particular direction. That is a spherical pair. It is one is the fixed and the mirror can move, having at the one end having a ball. So when mirror moves in certain angle of rotation according to your convenience for visibility. So the pair between this fixed link with respect to the mirror, that is the spherical pair. So the spherical pair will have surface contact and 3 degrees of freedom. So what is the spherical pair? There is a ball and socket joint is the 3 degrees of freedom. So what is the degrees of freedom of a sliding pair? Equal to 1. And the degrees of freedom of a turning pair is equal to 1. And the degrees of freedom of a spherical pair is not 1. It is 3. Next, helical pair. Helical pair, another name is called, it is known as a screw pair. It is also screw pair. So helical pair is nothing but a screw pair. So nut and bolt, it is a screwing, having a relative motion. So the degree of freedom of nut and nut for a helical pair equal to, that is also 1. Next, very important question. Generally, students, what is the elasticity and why steel is having more elastic than rubber? Generally, we think that elasticity means the deformation, quick deformation taking place. That is called elasticity. No. According to the physics, more elastic means if it offers more resistance to deform. That is the meaning of elastic, more elastic. That's why steel, at the same load, if you apply the rubber can deform very quickly and it comes back. Whereas the steel, it resistance to deformation than other bodies. That's why the steel is having more elastic than rubber. Okay. So elasticity means the property of the material which regains its original shape after removal of the load, applied load. Then it is known as the elasticity. But we are counting as why steel is more elastic than rubber. Physics, again I am repeating here, according to physics it is labeled that when the material is having more resistance to deformation than other bodies, okay, then it is known as elastic. Okay, it offers more resistance. That is elastic. Now here, what is Young's modulus? Modulus of Young's modulus, that is E. E equal to stress by strain. It is a concept came from the strength of materials or engine mechanics also. What is the stress? Load per area or force per area. What is the strain? Delta L by L. That is F L by A times delta L. This is a manner we can calculate modulus of elasticity or modulus Young's modulus or modulus of elasticity. So in the case of modulus of elasticity, again it comes into the picture of elastic constants. What are the elastic constants? Are mu, Poisson's ratio, E, modulus of elasticity, K, bulk modulus, and one more is called G. So that is the shear modulus. These 4 are considered as elastic constants, are known as elastic constants. Okay, these are the elastic constants. Next definition is that what is static force and what is dynamic force? So dynamic force is the force moving a moving object puts an object when hits it. That is the dynamic force. But the problem is that support related to the support, it consists of relates to a static force. That is the difference between dynamic force and static force. So stopping relates to a dynamic force, supports relates to a static force. So dynamic forces from a falling object are vastly higher than the static forces from the same object. So this is the description of what is static force and what is dynamic force. Now, what is the difference between static dynamics and static mechanics and dynamic mechanics? So definition is that dynamics means function of the time. Statics means zero function of time in simple definition. So study of the forces on moving bodies. Moving bodies means there is a function of time. Then application of force when they are in motion. Statics means, study of all the forces and couples movements for a stationary object which is in its state of rest. Whereas the dynamics deals with the study of all the forces when the object is in motion. Now the point is that, very important, these are some definitions and terminologies related to introduction to a kinematics of machines. But there are some more definitions are there. The more definitions are that, what is inversion? And we consider next some more definitions, inversion. Next, types of links or constrained motions. Constrained motion or types of constrained motion. Next one is types of links. What is inversion? Inversion means by fixing one link, obtaining a different type of motions of the links in that mechanism, or obtaining different mechanism, then known as inversions. In the 4-bar mechanism, there are 4 links are there. By fixing link 1, you can see the different motions in the links of remaining link 2 and link 3 and link 4. By fixing link 2, the link 1, if you give input motion to link 1, and remaining 2 links, link 3 and link 4, gives in different type of motion. By fixing link 3 and giving input motion to link 2, the link 1 and link 4. Similarly, by fixing different links and giving input motion to input link and obtaining the variety of motion and the output links, all these fixing links and obtaining different mechanisms known as inversions. That is the concept. Next, what is constrained motion? There are 3 types of constrained motions. Number 1, completely constrained motion. Constrained motion. In constrained motion, there are 3 types are there. Number 1, completely constrained motion. Number 2, incomplete constrained motion. And 3, successfully constrained motion. Completely constrained motion means it is only having one directional motion, one component with respect to another, only one directional. Suppose, how it is one directional? Suppose your finger is having only one direction of rotation. It doesn't rotate completely counterclockwise. Yes, it may rotate, but this is the limitation. Or we can consider that a rectangular rod is moving in a rectangular hole. that motion is a completely constrained motion. Completely constrained, a rectangular rod is moving rectangular hole. It is having a motion. This is completely constrained. It is having another motion. It can't be rotated. Okay, there is obstruction, means it is constrained. It is constrained in a particular direction of rotation. Okay, you cannot transfer. That it is known as completely constrained motion. And another consideration, if we consider a cylindrical rod is moving in a cylindrical hole, it can having two things. One is a translatory motion, another one is rotary motion. Then that particular type of motion is known as a incomplete constrained motion. It is not constrained, it is having more than one motion. Then it is incomplete constrained motion. What is successfully constrained motion? When the system is moving with incomplete constrained motion under incomplete constraint, by applying external load, it becomes completely constrained motion. Then it is known as successfully constrained motion. When a system is under incomplete constrained motion, by applying the external load, it becomes a completely constrained motion. Then it is known as a successfully constrained motion. What is that meaning? Suppose there is a footstep bearing is there. When it rotates, it has a tendency rotation and also comes out. By applying the external load, what will happen? It will be inside the bearing and rotates only. Without applying the load, it is incomplete constrained motion. By applying the load, it becomes only complete constrained motion. Then this type of motion is known as successfully constrained motion. Then what are the types of links? Again, as we have studied types of joint, binary joint, ternary joint, quaternary joint. Binary joint, we studied what are the types of joints. Yes, links we have studied, binary, quaternary. But what are the types of joints if you want to study? What is a binary joint? What is quaternary joint? If the joint is having, suppose the link, binary link, this is only joint. This joint having connection to another link, the binary. If the joint is connected to another 3 links, this is quaternary, ternary joint. This joint is having how many links are connected here? At this joint, 3 links. Then it is ternary. 4 links, it is quaternary. So like that, each joint is connected to number of links. Based on that number, that indicates whether it is binary, ternary or quaternary. So in this session, we have learned the definitions and terminologies of Introduction to Kinematics of Machines to understand the velocity analysis, that is velocity and acceleration analysis of various mechanisms. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.